Why do we need a vector database? In the classic RAG, retrieval augmented generation, process, one step involves converting a given text into a vector and then searching for similar vectors in the vector database. So, if we have a vector database, it contains a large number of vectors, and we need to match our input vector with others in the database. The core of this process is searching the database to find vectors that are most similar to the input vector. The comparison logic involves comparing the input vector with another vector to calculate their similarity, and then comparing it with a second vector, and so on, to compute similarity scores. The top n vectors with the highest similarity scores, for example, the top 10 or 20, are then returned to the user. The entire comparison process is essentially a comparison of the input vector with each vector in the database, which leads to a complexity called O(n), where n is the number of vectors in the database. Additionally, we need a method to calculate the similarity between vectors. The most commonly used method for calculating similarity between vectors is cosine similarity. Cosine similarity essentially calculates how similar two vectors are. For example, given two vectors, x and y, we output a similarity score between them. The core idea of this method is to calculate the angle between the two vectors in a space. If the angle between them is small, the similarity between the two vectors is considered high. For example, suppose we have three vectors representing a cat, a dog, and a bird. The angle between two vectors will be smaller in some cases than in others, indicating that the similarity between certain pairs, like cat and dog, will be higher than between others. This illustrates the principle behind calculating cosine similarity. To compute the cosine similarity between two vectors, the time complexity can be expressed as OD, where D is the dimension of the vectors. With these analyses in mind, we can clearly see that when a user asks a question, which we can treat as a piece of text, the time complexity involved in comparing vectors is O(n) times OD. It is evident that when the vector database contains a large number of vectors, the value of n becomes large, and so does the complexity. Furthermore, as the dimensionality of the vectors increases, the complexity also grows. However, in real-world scenarios, when users submit a question, we expect the system to respond quickly. Therefore, a system with this level of complexity will not meet the performance requirements. So, what should we do? We need a vector database capable of quickly retrieving vectors, a new type of database designed for efficient vector search. In essence, we aim to reduce both of these complexities, O(n) and OD. These are the types of challenges that modern vector databases are designed to address.